Welcome back, Structures of Math students. This is Mr. Marquetta, your favorite math teacher, here to bring you some interesting information about fractions. We're going to study chapters 7.1 and 7.2 today. The first important thing we have to get familiar with is the idea of a common multiple versus a least common multiple. And we have another way to say it also, the least common denominator. And I want to make it really clear that the words really do kind of spell out just what you're trying to think about. We have the word multiple. We have to be familiar first with the word multiple. Then we have to establish the idea of what common means, and we have to also talk about what least means. So a number is the least common multiple of a set of numbers if it is a common multiple of each of the numbers. In other words, each number in the set is a factor, and if it is also the smallest number that is greater than 0 with this property. If the numbers in the set are all denominators of fractions, then sometimes we call the LCM the LCD. So we'll look at some great examples of that. I like to start by showing you one on the paper here. Let's take, for example, what are multiples? Okay, first, what is a multiple? Well, a multiple is going to be for example, if the number we're thinking about is the number 4, the multiples will be 4, 8, 12, 16, 20, and so on. Multiples means the numbers carrying on from 4 in a counting way with the times tables. Now, let's talk about another set of multiples. These are the multiples of 4. Let's talk about the multiples, and I'll call this multiples of 4. Now let's talk about the multiples of 6. That would be 6, 12, 18, 24, 30, 36, and so on. Now, I know that you guys already are familiar with this material. I'm sure you've seen this before back in elementary school and middle school. But I do want to just reiterate some things and make it really clear up front. These words multiple, common, and least, and how they play a role in our story of fractions. So starting with multiples. When we say multiples, multiples are numbers that can be divided by the original number. So the multiples of 4 are all the numbers that can be divided by 4. The multiples of 6 are all of the numbers that can be divided by 6, leaving no remainder. Now, what are common multiples? There are infinitely many common multiples between any pair of numbers. For example, in this situation, we have a common multiple of 12. We also have, if we went a little bit further here, we would have another common multiple of 24, as you can see there. Further, there will be more and more common multiples. In fact, the common multiples will follow the pattern of the times tables of 12, actually. So using that information, our common numbers are 12 and 24. Now, between these two, what is the least of the two common multiples? Well, there's the least one. So it's kind of 3 steps. It's a common multiple, it's a multiples of the number, and then it's after that, it's going to be common multiples, and then of all of the common multiples that they share, then we will select the least of those common multiples. Now, let's talk about ways that you could find the least common multiple. And there are a couple of different ways that you could go about finding a common multiple. First, let's talk about just simply multiplying. You can, of course, find a common multiple by multiplying, but you don't necessarily always get the least. For example, if we asked you to find the least common multiple for these 3 numbers, 8, 6, and 3, you could go through the work of actually just writing all of the multiples like I did here, and then investigate which are common and then select the least of those common multiples. Or you could do some other things to figure it out. But the first method that's not always practical is to just go ahead and multiply them all together. As you can see, it's a very large product. When you multiply 8 times 6 times 3, you wind up with 144. That's a very big number. You can use that number if you're doing things with fractions and you're trying to find least common denominators for fractions, because later on you're going to reduce and that number can be as big as you need it to be. It's not a big deal. But with regard to the specific mathematical question, what is the least common multiple? The answer here is not 144. Now, for method 2, we could list some of the first multiples of each and then select the least common multiple, which is what I've done here. So let's see if we could pull that off using the numbers 8, 6, and 3. Okay, I would do that. And I'm going to change my view again so you can see what I'm writing. I would start by writing all of the multiples of 8. So the multiples of 8 will be 8, 16, 24, 32, 40, 48, 56. I'd kind of go as far as I kind of basically could in without going really crazy, but I went kind of as far as I kind of could. Let's do that with 6 as well. The multiples of 6, 6, 12, 18, 24, 30, 36, 42, 48, and so on. Then for the multiples of 3, I have 3, 6, 9, 12, 15, 18, 21, 24, 25, 20, 27 rather, 30. Great. Now, what are the common multiples? The first multiple, of course, would be, let's see here. I guess we'd have to go a little bit further than this, wouldn't we? Because I don't see anything that they have in common. I mean, I do see that 6 and 3 have a lot of things in common. But the first one that I see that they will have, yeah, go ahead.
They all have 24 in common.
They do. They all have 24 in common. You know what? I totally missed that. Yes, they do. I'm glad you said something because I was about to carry on. If we were to carry on, we could keep on going with the 3 and we would also get the 48 there, right? So we have a match here. These are common, but then we also have these as common. Is there anything lesser than this that is common? The answer is no. So our least common multiple this time is actually 24. And there are other ways to get 24 as your final solution. That's a little bit easier than this, and I'm going to show you that as well today. Okay. Let's take the same numbers, 8, 6, and 3. And right now, we're going to use prime factorization to try to write out what they would be as prime factors. So this is 2 times 4. 4 is 2 times 2, and just bring down the 2. Right? So for 8, we have 2, 2, 2. Now for 6, we have 2 times 3. And 3 is prime, we just have 3. So now, how can we figure out what the least common multiple is using these prime factors like this? Well, first what we do is we go from one thing to the next. We do each one, okay? We say, do we have a 2? Well, we have a 2 here. And we're also going to use this 2 up, so there's one of my 2's. So I've used one of them, all right? Do I have another 2? I have a 2 here. I'll use a box, and I have no other 2's, so I'll write that 2. Maybe I'll keep the circle and the box around it to try to keep a format to make it clear. How about this 2? I'll use a triangle for this one. No other ones, right? Okay, moving on, I've used this one here. How about 3? I'll use a cloud for 3. And since 3 is also in this one, I'll also use it up as 3, as a cloud, meaning that I've used it already. So you go across with the factors you got out of prime factorization, and I will show you a couple more examples of this to make it clear. But this is a great way for kids to learn about a good application of prime factorization, and also for you to get the answer to it, the least common multiple, is a little quicker than writing out all of these common multiples, which really does take up a lot of time, right? So what do we get when we multiply all this together? Yep, you guessed it, we get 24. And this is what we call a prime factorization method. They discuss this in your book. I'd like to do another example of this before we move on, just to make sure everyone's really clear on it. Let's do something with 3 other numbers. How about this time we use 15, 9, and let's use 10. Okay? I'd like to find the least common multiple of these. So I'll begin by writing out the prime factorizations of all 3 numbers. This will be 5 times 3, right? This one will be 3 times 3. This one will be 2 times 5. Very basic prime factorizations this time, but we're trying to prove a point and we're trying to illustrate the way that you go about finding the least common multiple for these two numbers. I think you know because of your math sense, just glancing at these three numbers, obviously they're very big numbers. So they're going to wind up with a very big number that's the least common multiple, and that's okay. It's for the purpose of practice. We're going to see what it would be. So we start with the first one and we use the first one. The first one is 5. So I'm going to use 5 and I'm going to see, does 5 exist anywhere else? It does, it's here. Okay, so I'm going to use 5 in my least common multiple. The next number is 3. Here's 3. Do I see 3 anywhere else? I see it here as well. Do I see it in this number? No. Now notice with this little algorithm and procedure, you only look at each number for one of the 3's. I only used up one of the 3's here because you do one number at a time. There's no 3 in here, so there's nothing to write in the box. So now I have 3 in the box here. Carrying on, what's the next number that doesn't have a shape on it? This one. So let's put a triangle on it and say this is the 3 with the triangle. Anyone else have a 3 that can get a triangle around it? No. This one's already been used. This one's already been used. There's nothing over here. So I'm going to use 3 once again with a triangle. And now I'm going to see, of course, I have only one thing left, and it's the 2. Let's use the cloud for that one. And when you multiply all together, you'll get 90. And your solution here this time, my friends, is 90. And you can find least common multiples using prime factorization in this way for any set of numbers. It could be 4, 5, 10, 15 numbers, and you can find the least common multiple. It's a little bit easier to do it this way than to do it with the other procedure where you list all of them. However, like I said, it's up to you how you want to do it. There's also a function in Excel that if you type into Excel a certain syntax, it will tell you exactly the least common multiple. You can find out how to do that by going to Google and just searching for it. But there are other ways to find least common multiples. This is my favorite way to use it because if you're familiar with this and you can help students understand this, then you'll help students later on when they're in algebra class, when they're learning about rational expressions and finding least common denominators with polynomials. The same rules apply, how you would use up one expression or one quantity, and it's kind of used in the same way. These shapes represent where they can be used again and so on. All right. So, like I said, for method 2, if you want, you could list them. And we did that on the paper, and that's what they look like as a list. And like you said, 24 does appear there. And I wish I looked at this PowerPoint before I started writing. I would have saved some face, and it would have been clear up front that 24 is the solution. So that's why 24 is what we want here. First, we list all of the multiples. Then we identify all the common multiples. Then we select the least of those. The next thing we're going to talk about is how to use geometry to answer questions about fractions. So the next couple of lessons you'll see on these slides are new geometrical ways to represent computations with fractions that you may not have seen before. Some of them you may have seen before. I'll warn you now as you look at them, some of them you're going to feel like they're really inaccurate or inappropriate when it comes to trying to convey the message. You might feel like they're really the kind of thing you might not want to use. And then there are other things in here that you'll see that you might think to yourself, now that I could understand, and I'm sure I could get my students to understand fractions using that tool. So it's up to you as a teacher looking at the next couple of geometric approaches to fractions that you're going to see, which ones you think are worthy of being taught in your classroom. And that, of course, is up to you. All right. Here's the first one. We're using a number line. So how can we use a number line? Well, we begin by looking at the denominators, and you'll see that we have 3 and 6 in our denominators. So what we do for 3 and 6 is we go out of our way to purposely multiply them. So we think, what is 3 times 6? And the answer is 18. Okay. So what we do now is we draw a line, and we go from 0 to 1 only on the line. And what we do is we cut it up into exactly 18 parts. So these marks there are 18 of them. And there are 18 little spaces here to represent 18 parts of a whole. So now you ask the question, well, we need to know what a third is and we need to know what a sixth is. So for example, a third of 18 is 6. A sixth of 18 is 3, which means that If you wanted to find out what a third looks like, go to the other number 6. If you wanted to look at what a 6 would look like, you go to the other number 3. For example, how can I express 1/3? I would use 6 spaces. Look very closely, they've used 6 spaces. Why 6? The reason why you're using 6 is because 6 is the other number in the multiplication. The multiplication here is 3 times 6 equals 18. So I have 18 spaces. So to find out what a third is, I'd use 6 spaces. To find out what a sixth is, I'm going to use 3 spaces. And this connection is something that students will use often and over again, and it will make them understand the quantity represented by 1/3 and the quantity represented by 1/6, and how 3 and 6 are intertwined that way, that 1/3 is 6 units, 1/6 is 3 units if you have 18 units, and how they're connected. Also, the commutative property shows up a little bit, and the kids in their imagination, when they're trying to reason and understand this, the commutative property is helping them understand this because of the idea of how 3 times 6 is the same as 6 times 3. And you can see that in a visual way here for the in geometry for the visual learner, okay? So what we would do then to create a diagram like this to compute 2/3 plus 1/6 is chop it up into 18 parts. We get 18 because 3 times 6 is 18, and then represent the third with 6 units. So 2/3 is 6 units here for the first 1/3. The second 1/3 then is another 6 units. So these two arcs represent 2/3, which is the same as 12 units. And then last we have 1/6. We could put 1/6 here, and 1/6 we know to be 3 units. So now all we have to do is just count the units. So if you look closely, you'll see that we do have, after all, 15 units here. The answer is 15 over 18. And then of course you can use this number line again to cut that into parts and to look at it again, and it may come clear to you that that's the same as 5 over 6. Okay, but that's not what's important. What's important when you're teaching them this way is to just get the correct answer. I would accept an unreduced answer for a question like this because the lesson is about trying to use geometry to answer fractions. Reducing fractions is another situation and another lesson for another day. If we can use geometry just to get the students to at least get to a quantity that is correct, even though it may not be reduced, then we've made a lot of progress, and the kids have a lot of a background when it comes to geometry and looking at fractions. So let's come up with an alternative example and see this done again with another set of fractions. For this one, come up with something that's not too challenging. How about something like 3/4 plus 1/2, or let's make it 1/5. Okay, so if you're trying to figure out 3/4 plus 1/5, what you'll do is you'll begin by drawing a number line, excuse me, and make the number line go from 0 to 1 and try to cut it up into an equal amount of parts. So how many parts? The answer is 4 times 5 makes 20 parts. Okay, so we're going to start right here at 0. I'm going to draw a nice horizontal line going straight across. I'm going to try to cut 20 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I have 20 spaces, right? I have 20 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20 spaces. Just make sure that's right. Okay, now 1/4 is going to be the same as 5 spaces. 1/5 will be the same as 4 spaces. Using that information, let's try to represent 3 1/4s. So 1/4 will be 1, 2, 3, 4, 5. Another fourth will be 1, 2, 3, 4, 5. One more fourth, because I want 3, right? I want 3/4. So 1, 2, 3, 4, 5. All right. So far, I hope that makes sense. I have 3/4 being illustrated as 3 separate groups of 5 marks because 5 spaces or 5 marks is going to be 1/4. Now I need to show 1/5, which is 4 spaces. So I'll do 1, 2, 3, 4, and that's 1/5. Okay. And what do I have here? I have 19 total out of the 20. And there's your solution. Okay. So some of the things that you should keep in mind, my friends, when you're doing something like this is, remember you are the presenter, you are the teacher, you are in control of the lesson and of the classroom. So it's going to be really delicate which kinds of questions you could ask. Please make sure that your answers always add up to 1 or less than 1, I mean, rather. Like, in other words, what if you add 2 fractions and they're both greater than 1/2? You end up with a mixed number, meaning that you're going to draw things beyond the 1. You need for the students to have a finite, uh, simple thing that begins and ends. If you put it in a box from 0 to 1 like this, the students feel a little bit of a comfort and they're able to kind of explore just in the box and just this much. I would strongly advise against getting answers and sums that are greater than 1 for a question like this. So carefully choose what questions you want to ask. 1/5 plus 1/5 plus 1/2 is a great example of a question. 2 fractions that add up to a number less than 1, I would strongly advise for something like this. Also, I would not go too far with very large numbers with this, because if you make it many, many, many tick marks, like what if I did 8 and 13? You've got a really large amount there. You're talking about a lot of tick marks, and the students are going to get lost in the tick marks, and they're not going to learn the point and absorb the idea in the lesson. The lesson is that we want it to be that you can think of 1/4 as a group of 5 things and 1/5 as a group of 4 things. And there's an underlying, almost subliminal lesson in this, that we're not exactly telling you that 4 times 5 is 5 times 4, but you'll see it as you keep working with these kinds of examples. Okay, so you will be responsible for being able to make number lines and things like that for your next exam. That will be something that you'll see in your essays, which are at the end of our slide. So here's another great example. Try this method to compute 3/5 plus 1/10. We're going to take a very short 15-minute break, my friends, as we always do when we get together to study math. Right now it's 8:30. Please return to class at 8:45. And in the meanwhile, I'm going to ask you to please try to figure out the answer to 3/5 plus 1/10 using number lines. Thank you, students. We are back and we're going to talk now about how you would go about answering this question here. We're thinking about 3/5 plus 1/10. So to do that, you may feel a little bit more compelled to use 10, of course. But remember what the lesson is about. The lesson is about using the number line to try to answer questions like this. So what we're going to do is we are going to actually take a minute and draw out literally 50 little marks. And it won't take really as long as you think, but we do have to work through that. And that is going to be a regular part of our practice with these number lines. So first I'm going to put the question up here. And now I'm going to draw a number line with 50 marks because I'm thinking about how 5 times 10 makes 50. So it's 50 spaces. So starting from here, I'm going to go straight across. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 8, 9, 30. 2, 3, 4, 5, 6, 7, 8, 9, 40. 3, 4, 5, 6, 7, 8, 9, 50. Now, it might be practical to do it this way, where you put like every 10th one a little bit bigger if you want. I would instruct the students to do that when you have larger quantities. Sorry, I'm trying to get my camera right here. Okay. So doing it this way, starting with 1/5 is 10 spots, right? So I'm going to write 1/5 equals 10 spots or spaces. 1/10 equals 5 spots. So if we want 3/5, we're going to need to do 1/5, which is 10 spots, which is here. And then that's 1/5. Here's another 5th. And here's another 5th. Okay, so we've got 3/5. Now, how do I show 1/10? 1/10 is 5 spots. So 1, 2, 3, 4, 5. There's 1/10. How many do you have? 10, 20, 30, 35. And I think, of course, you can reduce that, but remember what the lesson is about. This is about the first step, which is just using the number line to get an answer. All right. Okay. For the next activity, we're going to use a strip diagram to represent the idea of subtraction with fractions, and we're going to show how you can do this using a rectangle cut into boxes. Now, the boxes are also the product of the denominators in the same way that when we did our number line, we had the product of the denominators being used as all the numbers of the spaces on the number line. To do something like this, if you want to show 1/2 minus 1/3, first you have to try to understand what a half is, and then you have to understand what a third is. So here's an example using that box structure. Okay, so you're trying to figure out 1/2 minus 1/3 right now is the goal. And you have a strip diagram rectangle cut into 6 parts, like so. Now, you could think to yourself, okay, 2 times 3 makes 6. So 1/2 equals 3 boxes. 1/3 equals 2 boxes. This is the same logic that came from the number line example. And since that be the case, we could start by circling 1/2 or shading in 1/2, which is going to be 3 boxes, right? Like we said there. And now we're going to subtract 1/3, which is subtract 2 boxes. I'll show it with a circle. They show that often. something where you do a larger ones minus a smaller one, where there's shading for the larger quantity and a circle for the lesser quantity. The circle for the lesser quantity, now there are 2 boxes in this lesser quantity. So the answer is 2, and the denominator will be 6, like so, because we have 6 parts. We're also asked to do it for 1/4 minus 1/3. Let's take a look at what that would look like. If you're trying to find the answer to 1/4 minus 1/3 using this structure, you would think about using a strip diagram that has 12 boxes. Okay, so 1/4 is 3 boxes. 1/3, sorry, is 4 boxes. That be the case, we're doing 1/4 minus 1/3. Oh wait, is it 1/3 minus 1/4? Hold on. Yeah, that's written backwards. Sorry. The question is written backwards. It should be 1/3 minus 1/4. That being the case, 1/3 is 4 boxes, so we'll shade 4 boxes. There you go. And now we'll circle 3 of them. I wish it would stop doing that. It's auto-focusing. I'm sorry for the blur. I'm working on trying to get that fixed. So it would be these, right? And now, we see that there are only 3 in the circle. So it's 3 on top, and then what is the denominator? Well, there were 12 spots, so it's 12, like that. And of course we would reduce, but again, remember, the idea is to get the kids to be able to come up with an answer just using the geometry, and we're not focusing on the reducing lesson yet. That is an important lesson, and it is important to encourage your students to always reduce to the lowest terms, but this is the first time you're ever going to show them fractions. You want to show them fractions using structures that are concrete and easy to move around and think about, and we want them to be happy when they get to a solution. Remember, there's only so much work you can get out of them before they start to tire and get exhausted. 3/12 is a great answer, and it tells me that you're using the geometry correctly, that you're able to understand the connection between 1/4 and 3 boxes, and so on. And you know, we can skip the idea of reducing just for this. Then we can carry on and do enrichment after you do a reducing lesson, where you come back and revisit this question and also this question with the number line, and make sure that the students do one more step and just reduce their final solutions. So now we're going to talk about the procedures for multiplying fractions, and there are several cases. We're going to start with this case. This is our first case. Just multiply the numerators and then just multiply the denominators. So for example, if you're looking at a case like 2/3 times 4/5, you simply just multiply 2 times 4 on the top, and you multiply 3 times 5 on the bottom, and you finish up, and it's 8/15. The numbers 2, 3, 4, and 5 are used as an example. Here we have a structure that uses 4 variables, A through D. For the lower grades, you might want to use the star, the circle, the square, and the rectangle, or something like that. But you just want them to have the idea in their head that when they see fractions being multiplied, that they multiply the tops and they multiply the bottoms. It might be practical to start your lessons about fractions with the students, making them do multiplication first before they do addition, because it'll familiarize them with fractions, and it's got less of a workload than adding and subtracting fractions. So we're going to now talk about how you can interpret multiplication using a rectangle, and also how you can interpret multiplication using a number line. And again, you may or may not feel like some of these are practical and some of them aren't, depending on what you think you want to do with your class when you're teaching. So here's an example. 4/5 times 2/3 makes 8/15. How can we do that with a rectangle? Well, you're going to do it in steps. You're going to first make a rectangle to represent the first quantity, 4/5. Then you're going to take that same rectangle and draw it again, just the way you drew it, and include more writing in it to include the idea of thirds in it. And then the final part will have the final answer. So we start with a blank rectangle like this, and we cut it up. It hasn't been cut up yet, but it's about to get cut up. First, we show, well, we cut it up. You could cut it up right now. It might actually be more practical to do that right up front. Noticing that the denominators are 5 and 3, we make a 3x5 rectangle. So I'm sorry, my friends. Yes, you do have to cut it up in the first initial spot. So you draw the rectangle and you make it a 3x5 rectangle using grid lines to represent, you know, 3 horizontal rows and 5 vertical columns. Now, you'll shade 4/5 of the rectangle, which should be easy to do because you did just deliberately cut it up so that it's easy to see as fifths. Now, what you have there in blue is the new rectangle that you should be thinking about. And in blue, now you have to think about taking 2/3 out of that blue. So one of the rows is 1/3, which is why if you mark it with an X, it would look something like this. So can you see the process, my friends? It begins with an initial rectangle that has the dimensions that are the same as the denominators, 5 times 3, or 5 by 3 is shown here in this rectangle. Then we take our first fraction and show it by doing shading, where we shade in the first 4 of the 5 columns to represent 4/5. And then we take that same image we just drew and once again add more writing to it by putting X's in 2/3 of the boxes that have been shaded. So now you're looking at a great example of how to interpret multiplication using a rectangle. In my opinion, this is a really outstanding way to express multiplication of fractions with students. And you might also find that when you're doing fractions on your own, if you're taking the praxis or if you're taking a test somewhere and you have to multiply fractions, this is another easy, quick way to multiply fractions where you don't have to think too hard about your times tables. A lot of students kind of almost try to avoid getting into tangles with the times tables that way. You know. So here we have a good example. Try this method to show 3/4 times 1/3. So if we're trying to do 3/4 times 1/3, my denominators are 4 and 3, so I'm going to use a 4 by 3 rectangle. So let's start by doing 4 columns and 3 rows. Okay. Now, I like to start by doing, this is my first step, all right? Your next step will be the same image again. And again, you don't have to be an artist and use a ruler, just do the best you can, but this is step 1, which is draw the rectangle. Here's step 2, which is illustrate the first fraction. So 3/4, if these are fourths, right here, so if these are fourths, I can't get it to stop doing that. I'm sorry, guys. I know that that's very difficult to see. I got to fix that. 3/4 would be, if we have this, we have 4 columns, so 3/4 ought to be this piece here. There's 3/4. Now, of the 3/4, let's try to show 1/3. Well, these are the thirds, right? So we'll draw the figure once more. Okay, here's step 3. And for step 3, I already have this part shaded in, right? Now we're going to show 1/3 of it. I'll use a different color to show it. 1/3. Here are the thirds. It would be this, right? So now out of the whole, what do you have? You have 3 X's out of 12. You do 3/12 is your solution. That's what you're looking for there.
Does it matter if it's like horizontal or vertical? Like if we wanted to, we could have done like a vertical, like 1/3. That makes
Yeah,
sense.
absolutely. You could have done
Yeah.
it like this. Yeah, it would look just like this basically. And yes, you could do it sideways or the other way. It doesn't make a difference. Okay. And our last thing that we're going to talk about now is how you would do that with a number line. And it's the same case, but you know, I'm going to just throw this out there and I'm going to tell you that I have a little bit of a bias against this one. I don't really like this example. In my opinion, I would stick to using the rectangles that you see here in our video than using this. But again, that depends. That's my personality and my attitude. You know, you might feel that this is very appropriate and you'd like to use this. I do need you to be familiar though with all of them for your next assessment, okay? So let's talk about how we would do this. Well, we would draw a number line. And you might want to use different colored chalk, like they have blue chalk and green chalk here going on. So You have a number line, you draw 0 to 1, and you cut it into 15ths. When you cut it into 15ths, you also mark off the fifths. So I have 1/5, 2/5, 3/5, etc. I feel like if you're going to go this far and mark off all those fifths and start doing this, you might as well just do it the hard way. That's my attitude about it. I feel like this is harder than trying to do it with the old school multiply across and reduce. So anyway, you would draw a blue line to represent 4/5, and you could see the blue line goes from 0 to 4/5. Then you would draw a green line to go from 2 to 13. I'm sorry, to show 2/3, which is supposed to be 1/3 is 5. And you can see we have 2/3 to show. So we have 1/3 of it, 2/3, and the whole. So what we do is we actually take the purple line itself and cut it into thirds. So if you cut it into thirds, the green line represents one of the thirds. And the reason why we're allowed to do that is because there's a total of 12. There's 12 spaces, and a third of 12 spaces is 4. So the green line is 4 spaces. It would be 4 plus 4 because it's 2/3, so it's 8. I mean, that's what I'm trying to say, my friends, is why not just draw the rectangle? It's 10 times easier than this. But you start by doing a blue line to represent the first fraction, 4/5. Then you think about 2/3, but you say, okay, let's start with 1/3. You say, okay, that's 12 spaces. A third of 12 spaces is 4 spaces. So a green line is 4 spaces. Now 2/3 is 8 spaces, so it's 8/15. Again, it's up to interpretation. It has to do with what you think and where you are and what you're teaching and what you think is right. Here's another example that you could do. You could do 3/4 times 1/3. If we were going to do that, I'd show you just how to do that. 3/4 times 1/3 would look like this. Okay, so on a number line, if you want to do 3/4 times 1/3, you have to begin by drawing a number line that has 12 spots. All right, and the next thing you're going to want to do is try to represent 3/4. So starting by thinking about how 1/4 is 3 spaces, 3/4 ought to be 9 spaces. So here's my 9 spaces: 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's my blue line. Now I'm going to try to use the green line. I'll use red for the other one. So for 1/3, that is 4 spaces. Oh, I wish this would stop autofocusing. I have to figure that out. So if I have 4 spaces, meaning 1/3, that's what it would be like out of 12. But instead of thinking about this, what I do is I look at this and I realize that I've used 9 spaces. So I think, what is a third of these 9 spaces? A third of 9 is 3. So I'm just going to go like this. Now, this time it's only 1/3 they want, not 2/3 or 3/3. It's only 1/3 that they want. So if I look, I have how many total? 3 here. So this is representing 3 spaces. So my solution is 3 out of the total 12 spaces. And I think you can see that is the correct answer. And of course, you'd reduce. But once again, I would definitely rather do this question with the rectangle. But this is the logic involved. It starts with thinking about 3/4, so then examining what is 1/4. And 1/4 is 3 spaces. So 3/4 is 9 spaces. Draw a blue line representing the 9. Now, of the blue line, remember 1/3 does mean 4 spaces if it's of the whole thing, but you're trying to find 1/3 of the 9 spaces here. So it's really only 3. That's why this goes only 3 spaces. And now the answer is 3 in your numerator and the total 12 in the denominator. Okay, so that's all we have for today's lesson, and thank you so much for your close attention. And I also do appreciate you opening your mind and trying to look at fractions using geometry today. And I think that you'll find that when you're teaching the lower grades and you're helping the children learn, that this stuff actually does bring across the message of how fractions work. There are 2 essays associated with this lesson that will be on your next exam. There's going to be 4 essays like there were in the first. It's going to be 4 essays again. And for this one, there are 2 essays, and they're associated with drawing the rectangles and so on, and they're right here. I'll also post them later on closer to the exam when the time is right for that. And I also have WebAssign number 4 available for you, so you could go into WebAssign and go and begin that and start on that. There's questions there associated with everything you've talked about here. And just as a reminder, make sure you're reading and outlining those chapters because the questions on the exam are very closely associated with that. Let's take a minute right now and let me take attendance. And then after the attendance, we will dismiss. And then if there are any questions, you can bring them up. And thanks so much for your attention, my friends.